If you missed class today, what we started in Chapter 5 was factoring. All of Chapter 5 will be on factoring, so I wanted to make a little video in case you weren't here, because you need to know how to do what we're doing today in order to be able to do what we're going to do in the next 2 classes. This is sort of the foundation. So what we did today was we started to factor. And all factoring is we're breaking a number down into a product of factors, meaning I'm breaking something down into 2 things that multiply together to get me that original value. For example, a real basic example would be if I were going to factor the number 12, I want to break it down into its factors, or break it down into 2 numbers that multiply together to get me 12. So for example, 3 times 4. 3 and 4 are factors of 12 because you can multiply them by each other in order to get 12. So they're both the same value, they mean the same thing, but they're just written in 2 different ways. This is the factored form, right? And then this is the product, okay? So with that example, what we've been doing is multiplying, all right? For example, we have something like this. 3 times x plus 4, right? In order to multiply those together, what we've learned to do is distribute. We have to distribute the 3. This is saying 3 is being multiplied by this whole thing. So I multiply 3 times x, and I multiply 3 times 4. So 3 times x plus 4 is equal to 3x plus 12. That's what we've done up to this point, right? This is the factored form. This is the product once we actually multiply together. So what we're going to do now is we're going to start here, and then they want us to go backwards and break it back down into the 2 numbers that we're going to multiply together to get us this. So we're kind of undistributing in a sense. Okay. In order to do that, the first kind of factoring we're going to do is taking out a greatest common factor. So for example, if we have 4x plus 8, I want to break that down into 2 things that I can multiply together in order to get me 4x plus 8. All right? So what I'm going to do is I'm going to find the greatest factor that they have in common, the greatest number and variable combination they have in common. So I look at the numbers first, right? 4 and 8. The greatest factor they have in common is 4, because 4 will go into 4 and it will go into 8. So I'm going to divide that out, or factor it out, right? Then I look at the variables. This one has an x, this one doesn't. So they don't have any variables in common, so we can't take it out. So the largest common factor we can take out is 4. 4 will go into 4x and it'll go into 8. So I know that 4 is a factor of 4x plus 8. That means now I just need to find out what I'm multiplying 4 by in order to get this. A couple ways we can think about it. When you're factoring out a value, you're actually dividing it out. So if I had 4x and I divided out a 4, right? 4 divided by 4 is just 1, and then the x is still there, so I'd end up with 1x. Bring down my plus. 8, I divided out a 4. 8 divided by 4 is 2. So when I factor out that 4, everything in the parentheses is whatever's left over after I do that. So when I took the 4 out, I had an x left and a 2 left. So this is the factored form of 4x plus 8. If I'm right, I should be able to multiply these back together and get 4x plus 8. So you can double check yourself that way. 4 times x is 4x. 4 times 2 is 8, right? You can just redistribute. Just distribute it back out like we know how to do already. If you get what you started with, you did it right, all right? You also want to make sure that there's nothing left in common in the parentheses, right? X and 2, they don't have any common factors, right? Because this one doesn't have any x's. And then 1 and 2 don't have a common factor other than 1, which isn't going to change anything. So we know we took out the greatest common factor. If there's still something in common here, we didn't take out the largest one, right? So that's one way you can think about it. Another way to think about it is, and I'll just make something up here. Yeah. All right, I'm gonna look at the numbers. They have a 3 in common. That's their greatest common factor. 3 and 6 is 3. Now I'm gonna look at the variables. They have, this one has an x, and this one has 2 x's, right? X and x squared. I can take out 1x because they both have 1. I can't take out any more than that. I can't take out x squared because this one doesn't have 2 x's. It only has 1. So I can't take out 2 x's if it doesn't have them. So there's, excuse me, there's my greatest common factor. So the other way you could think about this is, you know this times this has to equal 3x plus 6x squared. So you could, instead of dividing, kind of do it backwards and think, okay, well, what can I multiply 3x by in order to get 3x, right? 3x times what gets me 3x? Well, 1, right? Anything times 1 stays the same. All right, what can I multiply 3x by to get 6x squared? Well, 3 times 2 is going to get me 6. X times x is going to get me x squared. Okay, so if I want to double check myself, 3x times 1 is 3x. 3x times 2x is 6x squared. All right, so that's factoring by taking out the greatest common factor. We'll do one more. First, the directions are going to say factor. So what you're going to do always, no matter what kind of problem it is see if we can take out a greatest common factor. Going to make your life easier. In this case, that's all I want you to do. So we're looking, I got 3, 6, and 12. Greatest common factor, 3. Then I'm going to look at the variables. I've got an x here, and I've got an x squared there. So they all have at least one x. So I know I can take out at least 1x, if not more. So I'm going to look, and it looks like the most amount of x's I can take out is 1, right? Because this has 2 of them, but these only have 1. So I can't take out 2 x's if they don't have 2 x's to take out. So I can take out an x. And then I'm going to look, I have a y here, but I don't have y's in the other one. So they don't share that in common. So I can't take that out because it's not common among all 3 of them. So this is the largest common factor. That means this times something will get me this, all right? So I divided out of 3x. Well, 3x divided by 3x, that's just 1, right? 6 divided by 3, sorry, plus sign. 6 divided by 3 is 2, right? I divided out the x. It was there, I divided it out, it's gone. And I still have a y here. So I have 2y left over in this term. In the last term, minus, I divided out a 3, so I have 4. I had x squared, I divided out one of the x's, so I only have 1x left. So this is the factored form, and we can double check ourselves. 3x times 1 gets me 3x. 3x times 2y gets me 6xy, right? And then 3x times negative 4x gets me negative 12x squared. Because 3 times negative 4 is negative 12. X times x is x squared. So that's factoring by taking out a greatest common factor. And like I said, whenever you see a problem and it says factor, you always want to do this first. You always want to see if there's a greatest common factor you can take out first before you do any other type of factoring.